differential equations. Non-homogeneous differential equations. Differential equations. Okay. Non-homogeneous means not in the form of f of y by x or f of x by y. dy by dx equal to ax plus by plus c by a dash x plus b dash y plus c dash, where a, b, c, a dash, b dash and c dash are constants and c and c dash are not both 0, are not both 0. Then this equation is called non-homogeneous differential equation. Non-homogeneous differential equation, whereas dy by dx equal to ax plus by plus c by a dash x plus b dash y plus c dash. Okay, it's called non-homogeneous differential equation. That means x power 1, y power 1. Here not power 1. There is no x or y. Here also there is no x or y. Then this must be non-homogeneous. Therefore, it is called non-homogeneous dE. Non-homogeneous dE. To solve non-homogeneous dE, we can reduce the given equation to homogeneous differential equation. We can reduce non-homogeneous differential equation to homogeneous differential equation. Then we can proceed as usual. Okay. In non-homogeneous differential equation methods, there are 3 cases. There are 3 cases. Case 1, if b equal to minus a dash, if b equal to minus a dash, then grouping the terms and solve the given dE. Grouping the terms and solve given dE. Okay, b equal to minus a dA. That means dy by dx becomes dy by dx ax b equal to minus a dash y plus c by a dash x plus b dash y plus c dash, b equal to minus a dash. Now cross multiplication we get a1x dy, a dash x dy, b dash y dy, c dash dy, cross multiplication ax dx minus a dash y dx plus c dx. Okay. Here a dash x dy minus a dash y dx. Taking left side we get a dash x dy plus y dx. Next b dash y dy, c dash dy, ax dx, c dx. X dy plus y dx means uv rule, uv dash plus vu dash, that is d of uv. That means a dash d of xy, d of xy, that means x into dy plus y into dx. Next, remaining same, remaining terms same. Now integrating on both sides, we get a dash constant integral d of xy, b dash constant integral y dy, y square by 2, c dash constant integral dy y, a constant integral x, x square by 2 cx. C dx means cx. That is the plus constant k. That is solution of given dE. That is case 1. If b equal to minus a dash, case 1 b equal to minus a dash, then grouping the terms and solve given dE. dy by dx equal to ax minus a dash y plus c by a dash x plus b dash y plus c dash. Now cross multiplication we get a dash x dy b dash y dy c dash dy equal to ax dx minus a dash y dy dx plus c dx minus a dash y dy transform to left side, a dash common out, x dy plus y dx, that means d of x y. UV rule, x into dy plus y into dx. Next integrating on both sides, okay, we get solution of given dE. That is case 1. Next case 2. If a by a dash equal to b by b dash, a by a dash equal to b by b dash, okay, a by a dash equal to b by b dash, that means a by a dash equal to b by b dash equal to some constant k, that implies a equal to k a dash, b equal to k b dash. Substitute in given equation we get, substitute in given equation we get dy by dx equal to a equal to k a dash x plus b equal to k b dash y plus c by a dash x plus b dash y plus c dash. Therefore, here a dash x plus b dash y, here also a dash x plus b dash y. Therefore, put a dash x plus b dash y equal to v, differentiating on both sides, a dash plus b dash into dy by dx equal to dv by dx. That implies dy by dx equal to dv by dx minus a dash into 1 by b dash equal to kv plus c by v plus c dash, kv plus c by v plus c dash. That implies dv by dx equal to a dash plus b dash into kv plus c by v plus c dash. Next, variable separable. Next method is variable separable method. Okay, from this onwards variable separable method, only v terms, there is no x term, therefore dx into 1 remaining terms. That is case 2. If a by a dash equal to b by b dash, then we can proceed a by a dash equal to b by b dash equal to k. That implies a equal to k a dash, b equal to k b dash. Substitute in given equation we get k into a dash x plus b dash y plus c, denominator same, a dash x plus b dash y same, therefore put a dash x plus b dash y equal to v, that implies dy by dx substitute just in terms of dv by dx. From this onwards we can use variable separable method. That is second case. Of course, if first case and second case satisfied, that means first case is b equal to minus a dash. If b equal to minus a dash and a by a dash equal to b by b dash, then we can mostly preferable case 1, because case 1 is easy, grouping terms and integrating on both sides. Therefore, if there are both cases accepted, satisfied, if there are both cases satisfied, case 1 and case 2, then we can most preferably use case 1, okay, rather than case 2. Okay, we can importance to case 1 rather than case 2. Okay, now because case 1 is b equal to minus a dash, because only b equal to minus a dash, substituting, then after grouping the terms, integrating on both sides. Okay, that is case 2. Next, case 3. If a by a dash not equal to b by b dash, a by a dash not equal to b by b dash, then in that case we can proceed, put x equal to capital X plus h, put y equal to capital Y plus k, then dx equal dx, dy equal dy, because h comma k constants. Therefore, dy by dx becomes capital dy, d capital Y, d capital X, a into x plus h, b into y plus k plus constant by a dash into x plus h, b dash into y plus k plus constant. That implies dy by dx equal to ax plus by plus constant, ax plus by plus ah plus bk plus c by a dash x plus b dash y, a dash h, b dash k plus c dash. Okay. This term constant term, therefore, if constant is equal to 0, we can proceed with ah plus bk plus c equal to 0, next a dash h plus b dash k plus c dash equal to 0. Solve with these two equations, we get h comma k. If these two are equal to 0, then dy by dx equal to ax plus by by a dash x plus b dash y. From this onwards, this is homogeneous differential equation. Homogeneous, ax plus x power 1, y power 1, x power 1, y power 1. This is homogeneous differential equation. That implies, put y equal to Vx, that implies dy by dx equal to v plus x into dv by dx. Okay. From this onwards, we can proceed homogeneous method, that is put y equal to vx. Okay. From this we get variable separable method. Next, finally we can substitute h comma k values. From these two equations we can solve, we get h comma k. Finally we can substitute h comma k values. Okay. That is case 3. If a by a dash not equal to b by b dash, then put x equal to x plus h, y equal to y plus k. That implies dy by dx equal to a into x plus h, b into y plus k by a dash into x plus h, b dash into y plus k. D small x equal to d capital X, because h constant 0. D small y equal to d capital Y. Therefore, dy by dx equal to ax plus by remaining terms, a dash x plus b dash by remaining terms. These term equal to 0. That implies dy by dx equal to ax plus by a dash x plus b dash by. Solve, we get h comma k. This is homogeneous dv. Put y equal to vx, dy by dx equal to v plus x into dv by dx. That is problem number, that is case 3. Of course, in case 3, a by a dash not equal to b by b dash. If it is b equal to minus a dash, okay, case 1, then we can importance to case 1. Okay, we can most preferably use it to case 1 rather than case 3. Okay, that is non-homogeneous differential equations method. Page number 341. Example 1, dy by dx equal to 3x minus y plus 7 by x minus 7y minus 3. That is b equal to minus a dash, b equal to minus a dash, ax plus by plus c by a dash x plus b dash y plus c dash, b equal to minus a dash. Non-homogeneous dE and b equal to minus a dash, b equal to minus a dash. Therefore, proceeding case 1, cross multiplication and grouping, cross multiplication. X dy minus 7y dy minus 3 dy. 3x dx minus y dx plus 7 into dx. Minus y dx, right side terms, x dy plus y dx. That implies 7y dy plus 3 dy plus 3x dx plus 7 dx. U into v dash, v into u dash, that is d of xy equal to 7y dy plus 3 dy 3x dx 7 dx. Integrating on both sides, integral d of xy, integral 7y dy, integral 3 into dy, integral 3 into x dx, integral 7 dx. That implies we get integral d of xy, integral 7 into y square by 2, 3 into y, 3x square by 2, 7 into x plus constant. That is solution of 3x minus y plus 7 by x minus 7y minus 3. That is ax plus by plus c by a dash x plus b dash y plus c dash, b equal to minus a dash. Therefore, non-homogeneous differential equation are case 1. In that case, grouping the terms, cross multiplication, minus y dx goes to left side, x dy plus y dx means d of xy, remaining terms as it is. Next, integrating on both sides, integral d of xy, integral y square by 2, integral dy y, integral x dx x square by 2, integral dx x plus constant. That is